Welcome everybody from CIVIL-MECH-MATHS Concepts. It's Ramchandra again. And in this lecture, the last part of the question which I started 5 lectures before is to find the maximum deflection. In this lecture, we will discuss about the deflection of the beams, especially deflection of cantilever beam subjected to a point load at free end. We will be discussing in the course of time the various loadings and for the various beams. And in this particular lecture, we will be discussing about the deflection of cantilever beams, deflection in cantilever beams subjected to a point load at the free end. This is P is the point load. This point load in newtons. Please make a note. Dimensions are very important. And L is in meters in SI units. And E is the Young's modulus in pascals or Newton per meter square. I is the second moment of area or moment of inertia, that is meter to the power of 4. Delta is equal to, this is the deflection, delta is equal to PL cube by 3EI. PL cube by 3EI. When self weight is neglected. Deflection is equal to PL cube by 3EI. Please remember this formula. And the question, if you see, in the last part, what we have to do? Find the maximum deflection. Where will be the maximum deflection? Cantilever beam will be like this, subjected to a point load P of length L. The deflected part will be the deflection curve, it is not a straight line. Whereas in case of bending moment, it is a straight line. But in the deflection, it is a deflection curve. This curve is making an angle theta here, and this is the deflection delta, and this is the angle theta. The angle theta formula is theta is equal to PL square by 2EI. PL square by 2EI. For a cantilever subjected to a point load, please remember these two formulae, very important formulae. And please have an idea about the dimensions also. If P is not given in newtons, if it is given in kg, then we have to convert into newtons. Don't just like that put the value of P, whatever is given in the examination. Please see the dimensions. Let us cross check the dimensions. In this last 5 lectures, we have solved the first one. The value of x in kilonewtons is 1.1 newtons we have got. Natural frequency of the cantilever we have found. Maximum strain gauge reading also we have found. And in this lecture, we are going to find the maximum deflection without considering the self weight of the beam. Okay. Now, for any time, if you are going to solve a problem, it is always better to have a picture either in your mind or on the paper. The picture will be like this. This is a cantilever beam subjected to a point load 1.1 Newton, and because of that it bends like this, and this is the maximum bending. Wherever the maximum bending takes place, there the maximum deflection will be there. When you see the curve, deflection curve. Maximum bending takes place at this place. I am not talking about the maximum bending moment. I am talking about the maximum bending of the beam. Maximum bending of the beam takes place under the point load in a cantilever subjected to a point load at the free end. This delta maximum is given by PL cube by 3EI. Now, what is the dimension of the, let us check the dimensions first. Let us check dimensions, whether this formula is dimensionally correct or not. Left hand side dimension is equal to delta max. What is the deflection? Deflection is in distance. Distance is measured in meter. That is equal to length. And right hand side, PL cube by 3EI. P is in Newton, L cube in meter cube divided by 3 into, what is that? Young's modulus. Young's modulus is in newtons per meter square. Stress by strain, that is Newton per meter square into I is in meter to the power of 4. That is equal to Newton meter cube divided by 3 Newton meter to the power of 4 by meter square. Meter square and meter to the power of 4, when you cancel out, what happens? This 2 will be there. That implies RHS is equal to Newton meter cube divided by 3 Newton meter square. Newton get cancelled. Meter cube by meter square is equal to meter. 3 does not have any value in the dimensions. That's a constant. So the dimension is equal to in meter. That is equal to length. That means left hand side dimension is equal to right hand side dimension. It's always to perform this, either in your mind or on paper, to perform the dimensional analysis. Once you have completed the dimensional analysis, you know the value, that you are confident that your answer is going to be in meters and your answer is going to be correct to some extent, provided you should know this formula perfectly. And what are the inside elements or components values and their dimensions. Now we will try to solve it. What we have to find out? Maximum deflection. Delta max is equal to PL cube by 3EI. That is equal to P is 1.1, L is equal to 1 meter, and 3 into pi by 64 into d to the power of 4, that is I. D to the power of 4 is 50 mm is the diameter, d to the power of 4. 50 mm is the diameter, 5 centimeters is the diameter, that is 0.05 meter into E. E is 200 GPa. GPa is 10 to the power of 9 PA. Calculate this. Delta max is equal to, calculate this one. Let's try to calculate. 1.1 into 64 divided by 3 divided by pi divided by 200 divided by 0.05 divided by 10 to the power of 9. Please see the calculations. If I made any mistake, please say that it's a mistake. It's only what you call we are doing it. It's a 5.98 into 10 to the power of minus 6 meters. That is equal to approximately 6 micrometers. Then delta by L. Sometimes in the examination they may ask, find the ratio of the deflection to the length of the beam. That is delta by L ratio. What is delta? 6 into 10 to the power of minus 6 divided by L is 1 meter. That is equal to 6 into 10 to the power of minus 6 meters. That is equal to 6 mu. It is not meters, it's a ratio. 6 mu. 6 microns. Six microns is del by L ratio, delta by L ratio. Now, let us find out, even though it's not asked in the question, let's find out what is the theta, angle. I have already explained you what is the angle. Theta is equal to PL square by 2EI. These formulae are valid only for this particular case. Depending upon the loading and depending upon the type of the loading and depending upon the type of the beam, the formula will change. Then what is P? P is 1.1 into L square is 1 square divided by 2 into E is pi by 4, 64 into 0.05 to the power of 4 into 200 into 10 to the power of 9. GPA is equal to 10 to the power of 9 PA. GPA is equal to 10 to the power of 9 PA. Please remember, see my previous videos. You will understand the concepts of the dimensions and units of the stress. Stress units are very important, either pascals or newtons per meter square. 1 pascal is equal to Newton per meter square. Please, this is the SI unit. MPa is 10 to the power of 6 PA. KPa is 10 to the power of 3 PA. PM is Newton per meter square. You have to remember these units. Some questions are asked in SSC JE about the units of the stress. Let it be any stress, shear stress, bending stress, let it be tensile stress, compressive stress. Stress means force by area. Force is in newtons. Newtons by area is meter square. Now, theta is equal to after calculation we will get the answer as 8.97 mu radians. Theta is in radians. That is equal to theta is in radians. Approximately 9 into 10 to the power of 9 minus 6 radians. That is equal to 9 microradians. These units, how to represent them, these things are very, very important. Further to know, this last part I have taken, even though it's an easy one. It is just substitution, but still I have taken it because I want to impress upon that Pascal is newtons per meter square and angle is in radians and mu is micro and microradians, milliradians, micro strains, millistrains and MPa, GPa, all these values, importance, their practical importance and angle and this dimensional analysis, practical importance I want to impress upon. Hence, I have completed this whole problem. Now, from next class onwards, we will be discussing on the deflections of the beams of various shapes and also various lengths and with various end conditions like fixed end condition, continuous beams, simply supported beams, cantilever beams, free end conditions. We will go further. Now we have got the values, we have solved the total problem, and it's Ramchandra from CIVIL-MECH-MATHS Concepts. I have released around more than 63 videos under various playlists. In the description, I will be giving the link for the playlist. Playlist is, it can be for SSC JE and GATE. That playlist name and playlist link I will give. Please see all the videos under the playlist and try to get the maximum knowledge from it and try to ensure that you will get the concepts and do better in the examination. Best of luck to everybody. Thank you for listening to me. Thank you for viewing my video. Please remember these two formulae. Delta E is equal to PL cube by 3EI and theta angle is equal to PL square by 2EI. How we have got this? In the next lecture we will be deriving these equations. These two equations, we will do the derivation of these two equations in the next class, so that you will understand how we have arrived at these equations. Derivation, we will do it in the next class. Thank you. Best of luck to everybody. It's Ramchandra again from CIVIL-MECH-MATHS Concepts channel, and please subscribe to my channel, view my videos, and to the maximum extent possible spread this knowledge to everybody, to the friends, whoever you know. Spread this knowledge, let everybody be benefited. Thank you for seeing my lecture.